Okay, so this is 4.2 of Algebra 2. We're talking about functions and their inverses. So you have to be able to, and I kind of touched on this in 4.1, to determine whether a function has an inverse. So in order for a function to have an inverse, function, okay, can have an inverse that's not a function. But in order for the inverse to be a function, it has to be 1 to 1. Okay, so remember, if it's a function, it has to pass the vertical line test. For it to be 1 to 1, it has to pass both of them. So a function has to be, well, a function, an equation has to be a function to be 1 to 1. Okay? But it can be a function without being 1 to 1. Okay? So those are not interchangeable. Okay? So when graphed, so this is where we start talking about the graphs, and this is going to be really important. The inverse of the function has x and y values that are switched. In other words, the graph is just a reflection. Okay, so a reflection like in a mirror, but it's reflected over the line f of x equals x or y equals x, which is just a line starting at 0, 0 with a slope of 1 over 1. Okay, so your reflection is just from there to there. Okay, so whatever I draw here, okay, it's just going to be reflected on that side of that line. Okay, so that's actually what the reflection and the inverse is. Okay? It's a reflection across the line y equals x. So let's find the inverse of the point 3, negative 2. Well, when graphed, the inverse of the function has x and y values that are switched. So f of negative 1 of x would just be negative 2, 3. All we're doing is switching those two functions. Okay, same thing here. So graph the inverse of the function. So all we're going to do is we're going to take some points here. And I'm going to choose some that are on lines that I can easily move. So I'm going to choose those ones. Okay, so this point here is on the line y equals x, and so is this one. So those two are not going to change. Okay, but these other ones are going to change. And you can see there's a little bit of a lift there that's actually going to come over to that side. Okay. So now this one is going to reflect across. Can you have two choices? You can say, well, this point is negative 1, 1. So my new point is going to be 1, negative 1. Okay, or you can just reflect it straight across. Okay. So this point right here is negative 2, 4. So my new point is going to be positive 2, negative 4. So my graph is going to kind of come down and around and look like this. Let's see. And then this one is going to reflect across to there. Okay, so it's going to kind of go like that. And oh, and this point should be 4, negative 2, and it's going to go like that. Okay, so you can see that it's just reflected across that line right there. So let's take a look at these ones. So it says find the coordinates of the inverse function. So here's the function, the coordinates for this function, and the inverse function. So all we're doing here is we're just changing those x and y values. So negative 2, 1 becomes 1, negative 2. We don't change the signs on them. We just flip the two numbers. Negative 1, 2 becomes 2, negative 1. 0, 3 becomes 3, 0. 1, 4 becomes 4, 1. And 2, 5 becomes 5, 2. Okay, so that's all we have to do to find the graph of the inverse function. And then 4.2 says, is the inverse of the function x squared a function? Well, let's see what x squared looks like. So x squared, if we were to graph it in our calculator, actually looks like this. So is this a function? Yes, it is. It passes the vertical line test. Okay, is it 1 to 1? Okay. It does not pass the horizontal line test, so it is not one-to-one. So no, okay, our inverse is not a function because it is not, because f of x is not 1 to 1. Okay, and that's it for chapter 4, section 2. So go ahead and do your assignment for that. And then we are going to continue talking about functions. And this is stuff that you are not going to want to forget. So make sure that you're paying attention, studying, asking questions. Have a great day.